Okay, the length of a rectangle is 5 inches longer than the width, and the area of the rectangle is 84 inches squared. Which equation represents this problem if W is the width of the rectangle? This is a pretty standard word problem dealing with quadratics. So first we have to come up with the equation, and then we're going to solve it. So let's kind of get a visual of what our rectangle looks like. Now we don't know exactly how wide or how long, so it's just kind of a guesstimate. We're going to call this the width, and we're going to call this the length of the rectangle. And it says, so it starts to give some information. The length of the rectangle is 5 inches longer than the width. So you can actually represent the length with this expression, 5 inches longer than the width. So instead of using the variable L, let's use this expression, 5 inches longer than the width, which is like the width plus 5 inches. So that's the expression we want to use. What else is there? The area of the rectangle is 84 inches squared. So the area is on the inside, and it's 84 square inches. By the way, in case you're wondering, a square inch just means instead of just a one directional inch, like this line, this is 1 inch. A square inch, 1 square inch, is just like it says, an inch long and an inch wide. Just in case you're wondering about what does this inch squared mean, it just means a literal square. Okay, that's just other information, not related. So there's kind of a setup for here that you're supposed to have in your memory, and that is the area is equal to the width times the length for rectangles. So this is kind of background information that's just memorized. So let's kind of fill in this example. The area is 84 inches squared, so that will go right here, is equal to the width, which we're representing with W, times the length. And the length we're representing with the expression W plus 5, because the length is 5 inches longer than the width. So here's our equation. Let's try to get it into a form that we recognize better. So we're going to distribute into here. So W times W will give me W squared. And W times 5 is 5W. And then on this side, I have 84. I'm not ready to factor yet because I need this 84 over here with the rest of the quadratic. So I subtract 84 and subtract 84. Oh, I'm running out of time. It might get loud in here. 5W minus 84 is equal to 0. Here we can factor. So we solve just like we have been. I'm going to work fast because students are going to come in for lunch any second. So you think of all the factors. Okay, those are all the ways to create negative 84. You add them up. We're looking for the one that adds up to 5. And positive 12. And then you set these equal to 0 and solve. So I'm going to skip that step because it's going to be busy. When you solve, you'll get these two answers. Now for this word problem, it doesn't make sense to have the width be negative 12 inches. So even though when you're just doing problems, you get 2 answers, if you're doing a word problem, you have to see if those answers make sense. 7 inches, if the width is 7 inches, that makes sense. But the width of negative 12 inches, I mean, that's really confusing. So you ignore that one. So our width is 7 inches and our length is 7 plus 5 inches. It's 5 more than the width. So the length is going to be 12 inches and the width will be 7 inches. Okay, so we came up with an equation and we solved it. Please ask me if this left you confused. I'll be happy to explain it in class too.